Hi, so today we're going to be talking about adding and subtracting rational expressions. So the last couple of days we've been working on finding the least common denominator when the least common denominator has a variable in it. So I gave you 4 examples that I'd like you to find the least common denominators as a warm-up, and we're going to go over to make sure you really feel comfortable tomorrow. I do want you to write any questions you may have on those first 4 questions so we can go over it. But we're going to start by going to our first example on the second page, how to add and subtract rational expressions. So I gave you guys a step-by-step process that we're going to do. And adding and subtracting rational expressions is the same as adding and subtracting fractions. So let's just review that. If I give you 1/2 plus 1/3, you need to find the lowest common denominator. The lowest common denominator in this case would be 6. So you'd multiply this side by 3 over 3 and this side by 2 over 2, and you get 3 over 6 plus 2 over 6. Now that you have a common denominator, you would add the numerators and you would keep the denominator. The process is exactly the same, but it gets a little confusing because we're talking about things that have variables in them. All right, so let's look at our first example. The first thing we're going to do is we're going to find the LCD. So I look at it and I've got 8 over a squared b and 6 over ab squared. Remember, our LCD is every factor the most times it occurs in each expression. So for example, in our expressions, a's, the most times it occurs is a squared in either of the 2 denominators. In the second part of it, the factor of b, the most time it occurs in either of the denominators is b squared. So a squared b squared would be my LCD. All right, then you multiply the top and the bottom of the first fraction by the factors that are missing from the LCD. All right, so look at this. A squared b is missing a b. We need it to be b squared, so we would multiply by b over b. Okay? All right. And then on this side, the a and b squared, we're missing an a from that LCD, so we're going to multiply by a over a. All right, step 4 would be to simplify each fraction, so we're going to multiply, okay? Multiplying the top and the bottom, sorry, step 2 and 3. Multiply the top and the bottom, so 8 times b gives me 8b. Now, the denominator will then become whatever your LCD is, so a squared b squared, plus 6 times a would give me 6a. Over a squared b squared. All right, so now that we've simplified each fraction and the denominators are exactly the same, we add the numerators, we keep the denominator. So we add the numerators and we keep the denominators. So we're going to get ab plus 6a. All right, let's look at another example. All right, this one's a little bit harder. Let me just make sure you guys can see this on my screen. Okay, yeah, okay. So I know it's kind of blurry because it's small, but you have the sheet in front of you, so we're looking at example 2. All right, this one's a little bit harder. Now, because this is an expression, y minus 6, it is a factor that's in the denominator. So how many times does it occur, y minus 6? It occurs 1 time. So y minus 6 is part of my LCD. All right, this one has a factor of just plain old y, and it occurs 1 time. So y is also part of my LCD. So my LCD would be y and y minus 6. Okay, on this left fraction, what's missing from the LCD is a y, so I'm going to multiply by y over y. All right, what's missing on this side of the fraction is y minus 6. That's what's missing from my LCD. All right, now I'm going to multiply the top numbers, so the 3 and the y, and I'm going to get 3y. And on the bottom, I multiply them, and I will get my LCD as my denominator. On the right side, I'm going to multiply 1 times y minus 6, and I get y minus 6, all over whatever my LCD is. Okay, now the denominators are the same, so we add the numerators. So we're going to get 3y plus y gives me 4y minus 6. Okay? All right. I'm going to try one more example. So let's go to the next page. All right, so 3 over x plus 4 plus 4 times x minus 2. So the first thing we want to do, and we want to do it off to the right, is write down our LCD. All right, so we look at every product, and that expression is a product, that expression is a product. So my LCD would be x plus 4 times x minus 2. All right, so on this fraction, the left side, I'm missing an x minus 2. So I have to multiply it by x minus 2 over x minus 2. Whereas on this side, I'm missing the x plus 4. So x plus 4 over x plus 4. Now we really want to be careful here, guys, because we now have 3 being multiplied to an expression with addition and subtraction. So now, our LCD becomes our denominator. But this 3, we want to make sure we distribute through the parentheses to each of the terms in that binomial. So we're going to get 3x minus 6. Same thing on the other side. We have 4 being multiplied to an expression with addition and subtraction, so we don't want to forget to distribute. Oops. I did that backwards. It doesn't matter, but I want to write it the same way. So x minus 2, x plus 4, and the numerator then becomes 4x plus 16. All right, so now my denominators are the same. So what do we do when we add fractions when the denominators are the same? We add the numerators. So we have 3x plus 4x gives me 7x. I have a negative 6 plus 16 gives me positive 10 all over my LCD of x minus 2, x plus 4. Okay? All right, I am going to do actually one more, but I want to flip to the next page because I'd like to do one with subtraction. All right, so we're going to do number 6. Now I am going to do the rest in class tomorrow. We're going to practice them and we're going to spend a couple of days on this. But I'd like to look at number 6. So 1 all over x minus 1 minus 1 all over x. All right, so step 1 would be to calculate our LCD. And my LCD in this case would be x times x minus 1. Just going to take a quick look and make sure you guys can still see everything. Perfect. All right, so on the left side, what am I missing from my LCD? I'm missing an x. Let me switch colors. And on the right side, I'm missing x minus 1. So I'm going to multiply by x minus 1 all over x minus 1. All right, so I know I'm going to have 2 fractions being subtracted. I've got my LCD as x, x minus 1, and x, x minus 1. All right, so x times 1 will give me x. Here, 1 times x minus 1 gives me x minus 1. However, if you see this subtraction, that subtraction is being subtracted to this entire quantity. So with subtraction, my tip to you would be put that expression in parentheses so in the next step we don't forget to do something. Okay, what is it we don't want to forget to do? Well, now that the denominators are the same, we add or subtract the numerators. So I have x, but this negative has to get distributed to both the x and the negative 1 because it's subtracting an entire quantity. So that would become x minus x plus 1. These x's would cancel. Sorry about that. And I get 1 all over x times x minus 1. And there's my final answer. So again, with subtraction, you have to be really careful, especially in that top right fraction, the top right quadrant, if you want to think about it, because if there's something that ended up being an expression, you have to make sure that that negative gets distributed through. It would be a big mistake if you didn't. You'd get a very different answer if you didn't distribute your negative through, okay? All right, so tomorrow we're going to take this a couple steps further and practice it a little bit, and hopefully you'll bring questions to class tomorrow. Have a great night.